Tech. Hello, this is Tanner Tech, and today I'm going to be showing you how to make a control circuit for an RC plane that will work using a TV remote as the remote control. So, let's get started. So, the point of our project is to get a signal, an infrared signal, from a TV remote like this to control a small motor, or two small motors, on some sort of RC airplane with the minimal amount of circuitry. So, the thing we want to use is something called an IR photoreceiver. We are just going to take the signal that's coming from the remote and have this phototransistor turn on a bigger transistor or a smaller transistor. So that way we can just turn on and off the motors. So all this project will do is when you press a button, it'll send a signal to the IR phototransistor, which will go through some circuitry and turn on this fan motor, therefore letting us control our plane from the air. So let's get started. So what we need to know is, first of all, the pinout of this certain IR phototransistor. So what I've gathered from the internet is that the pinout is as follows: positive, ground, and the out. So the positive requires an input of anything from 3.4 volts to 5 volts, and the ground is of course ground. And now we need to see what the output looks like. So to test the output of this phototransistor on an oscilloscope, what we're going to do is we're going to plug the phototransistor into a breadboard and make all the connections to power, ground, and the oscilloscope, as you can see here. Now set the oscilloscope to the required voltage that you are putting on to your IR phototransistor, and now it's time to make it work. So I'm going to press one button on the remote control and we're going to see what happens to the oscilloscope output. Right now I'm pressing play. So as you can see, there's a square wave going on here. Now, the other thing to note about the output of this phototransistor is that when you press a button, instead of staying low and going high, it's staying high and going low. Which means that this pin always has a potential of approximately 3 or 4 volts on it, which would not be good if you were using an NPN transistor. So when you press a button, the output goes low, or to ground, which means that we can't use the standard NPN transistor that's used in most projects for turning on or turning off something, which means that we have to use another type of transistor called a PNP. Now, PNP transistors, such as this 2N3906, have a different pin configuration as NPN transistors, such as this 2N3904. So, what happens with a PNP transistor is, of course, you've got the base, you have the emitter, and you have the collector. But the difference being is that the roles, per se, of the emitter and collector are switched. Whereas if you have a positive voltage on the emitter and the collector is grounded, which is the vice versa on the NPN transistor, if the base is drawn to ground, or the collector, then the transistor will be turned on. But if the base has a higher voltage potential than ground, then the transistor will not conduct. So this is perfect for our purposes, because by connecting our phototransistor to the base of this PNP, when we press a button on the remote and it sends a signal to the phototransistor that causes it to be pulled to ground, it'll pull the base of this transistor to ground, activating it, which is what we want. So, now to drawing the circuit diagram for our little flight controller. So what we're going to want to do is we're going to want to have the phototransistor first, right here, and the phototransistor, of course, has the output, positive, and ground. So what we're going to want to do is we're going to have this hooked up to some positive voltage, which I'm going to put as this rail. And we're going to have the positive voltage be 3.7, because that's the voltage of the lithium-ion battery I'm going to be using to power this project. Now the output of this is going to be going through a resistor into the base of the PNP transistor. Now the reason I'm using a resistor is because if you hook up the PNP transistor straight to the output, the voltage will be too high and the current will flow too much through the transistor, shorting it out and therefore making it catch fire and burn up, which is something we don't want. So what's going to happen is we're going to take the emitter of this transistor and we're going to wire it to voltage. Now what we want is this transistor to activate an NPN transistor to activate the motors. So this end of the transistor is going to be wired through a resistor, which is 220 ohms, such as this one, which is also 220 ohms. And this is going to be going to the base of an NPN transistor. Now the NPN transistor, when it has a positive voltage on its base, it will allow the transistor to conduct. So what I'm going to be doing is I'm going to be drawing the symbol for a motor right here, and having it go to the collector on the NPN transistor, and the emitter is going to be going to ground. And so now there are just a few more things we have to add to this little schematic to make it work. Now, I've tested out the schematic as is right here, and the motor doesn't go too fast, which is telling me that the different pulses, which is about 33 kilohertz from the phototransistor, is acting as a PWM speed controller for the motor, slowing it down. So the way I'm going to fix this is by adding a capacitor to the base of this transistor, which is going to be a 470 microfarad capacitor. And what this little capacitor is going to be doing is it will smooth out the voltage coming into the base, and it will kind of smooth out the pulse width modulation, therefore making the motors run faster. So to make this thing work, the higher the value of your capacitor, the faster the motors will go, because it's smoothing out more of the pulse width modulation. So now to start the actual soldering process of this miniature RC plane controller. So the first thing to note that is, when you are soldering, the solder smoke that comes up from the actual solder is actually part of the rosin core of the solder burning up. And now, this smoke is extremely toxic because it contains lead fumes from the lead in the solder, plus formaldehyde and other cancer-causing chemicals from the rosin core. Now, this stuff is extremely bad for you and is known to cause cancer, lung problems, and other respiratory issues. So, I built this thing. I call it my miniature fume hood, and pretty much what it does is it's two computer fans blowing at high speeds, and it's sucking up the fumes through this two pieces of activated carbon filter. And what happens is this absorbs all the smoke chemicals and keeps them stored inside here, so I can safely solder under here without getting any of that hazardous smoke in my nose and my lungs. So this is the ideal way to solder if you don't want to die. Now, what I like to do is I like to solder my components one at a time. It makes it easier. So what I'm going to do is I already have the IR beacon inside, and what I'm going to do is I'm going to take my soldering iron, some bit of solder, tin the solder tip. Now I'm going to hold the soldering iron to the little bit of copper and hold it there, put some solder on, and it should be soldered. Now do this with all the pins, and you should be good. Now, please be mindful of that annoying background noise. That's my soldering fan. It's pretty loud. It's the sound of me not dying. Now that we have the first component in place, I'm going to add these cool things that I like to call rails. So what they are is they're a certain strip of little copper, little things of copper that I make sure are a certain voltage. So let's say this little line right here is going to be the ground rail. So this is where all the grounds are going to be going to. And this little rail over here, I'm going to call it the positive rail. So this is where the 3.7 volts are going to go to. Now this helps a lot when you're placing components because you can make sure to always place the negative leads in the right place and the positive leads. So I'm not going to go through putting every component in this video because this is pretty self-explanatory. All you need to do is match the different pins of your components to the different pins they need to be attached to of the other electronic components. Now, all you have to do this is make sure to use your brain when placing components, make sure they're in the right spot, in the right position, and make sure everything looks good. So another thing that we need to consider, since this is going to be going on an airplane, you need to make sure it's the lightest as possible so your airplane can fly good and go fast. So I'm just going to make sure to place all my components very tightly together, and I'm going to finish this up. I'll come back when I'm done placing and soldering all the components. So after about 20 minutes of soldering, I finally finished the circuit board. As you can see, I have all of the components placed on the board, and all of the soldering connections made underneath, using old spare resistor leads, and just putting the components close enough together to solder them. My power rails are soldered in. I have a little power connection for a little battery here, and I have my switch to turn it on. Then I have my two output connections to the motors. So, let's test this thing out. I designed this board with two pieces for extra connection. So on the top you see here, I have a place where I can connect this lithium-ion battery. So I connect the battery into these two terminals, and this is how it will be powered. Okay, so now I've got my my complete circuit board running. And since all of my lithium-ion batteries were dead, I just had to wire it to my power supply with the approximate voltage of a lithium-ion battery. What happens is I have the motor connected to those two little pins you see on the side. And as you can see, when I press a button on my remote, the motor revs up. So it honestly doesn't matter what button you press. I can press play, search, 5, any button you want on here, and it will make the motor work the same way. But anyway, this is a cool project that I thought I'd share with y'all, and I just think it's pretty cool. So you can just press any button, and it will run. So, thank you for watching, and please subscribe. Now, tune in tomorrow for my next video, which I will be posting in conjunction with Twit Aviation. In that video, we will show you how to make an actual airframe and propellers for these motors that will support this little piece of electronics, so that way this can actually be used to fly an airplane. So, see you then.